Buenas tardes y bienvenidos. Soy García, coordinador de BirdLife en Canarias. Arrancamos esta jornada sobre contaminación lumínica y aves marinas, organizadas por BirdLife y SPEA en el marco del proyecto Luminaves. Desde hoy y hasta pasado mañana, jueves 26, tendremos la oportunidad de escuchar a participantes de casi una decena de países que nos pondrán al día sobre las investigaciones más relevantes en materia de contaminación lumínica y que compartirán experiencias y casos de éxito en sus respectivos países. Me gustaría aclarar que como consecuencia de la situación sanitaria y para evitar problemas técnicos, se ha decidido pregrabar las intervenciones. En cualquier caso, al terminar las ponencias técnicas, habrá ocasión de interactuar con los ponentes en el chat en directo. Sin más dilación, a continuación les dejo con la mesa inaugural de las jornadas, que arrancarán con José Antonio Valbuena Alonso, Consejero de Transición Ecológica, Lucha contra el Cambio Climático y Planificación Territorial del Gobierno de Canarias. A continuación, Felipe M. Porteiro, que es Director Regional de Asuntos del Mar del Gobierno de Azores. Seguidamente, Isabel García Hernández, Consejera Insular del Área de Gestión del Medio Natural y Seguridad del Cabildo Insular de Tenerife. Manuel Amador Jiménez, Director de Medio Ambiente del Cabildo Insular de Gran Canaria. Domingos Leitao, Director Ejecutivo de la Sociedad Portuguesa para el Estudio de las Aves, SPEA, y cerrará esta mesa Asunción Ruiz, Directora Ejecutiva de la Sociedad Española de Ornitología, BirdLife. A continuación, después de la apertura, Pep Arco, responsable del programa marino de BirdLife, y yo mismo realizaremos una breve presentación introductoria que dará paso al arranque de la parte técnica de la jornada. Esperemos que las disfruten. Y ya, sin más dilación, les dejo con José Antonio Valbuena, Consejero de Transición Ecológica, Lucha contra el Cambio Climático y Planificación Territorial del Gobierno de Canarias, al que agradecemos enormemente por su participación y la implicación del Gobierno en este proyecto. Muchas gracias.
Muchas gracias y buenas tardes, y primeramente pues trasladar un saludo cordial a todos aquellos que asisten a esta jornada. Unas jornadas que son importantes, evidentemente. Importantes porque, como ustedes saben, el Gobierno de Canarias se ha marcado como un objetivo prioritario lo que es la acción climática. Y la acción climática no es solo la reducción de nuestra contaminación de los gases de efecto invernadero que emitimos a la atmósfera, que permitan de alguna forma ir mitigando los efectos, sino también una parte muy importante de adaptarnos. Adaptarnos al final a esta vorágine en la que la sociedad se ha metido en las últimas décadas, o más concretamente en los 2 últimos siglos y medio, donde hemos perdido algo que siempre teníamos de forma natural, que es nuestra armonía con nuestros espacios naturales, nuestra armonía con nuestra naturaleza, nuestra armonía con el resto de seres vivos con el que compartimos un mismo territorio, con el que compartimos un mismo planeta y que, por desgracia, sobre todo de forma muy acentuada en la última mitad del siglo XX y comienzos del siglo XXI, han visto cómo sus hábitats naturales se han visto de manera injustificada, alterados de forma muy sustancial por unas necesidades que el tiempo ha puesto en evidencia que tal vez no eran necesidades que tenían que ser solventadas. Por lo tanto, ahora toca revertir la situación. Y en un caso concreto, como son las especies, las aves, una de las especies más delicadas en la cadena, vital, en la cadena de la biodiversidad de nuestro planeta, junto con las especies marinas, necesita una atención especial. Y evidentemente, programas como este, trabajos como el que desarrolla BirdLife, son aspectos muy importantes frente a los cuales la administración pública no puede permanecer ajena. Y ya cuando en mi anterior etapa como consejero del Cabildo Insular de Tenerife había un compromiso decidido por la protección de las aves, impulsamos de manera decidida en las campañas de las pardelas con implicación por parte del Cabildo Insular de Tenerife. Se apoyó programas que, patrocinados por BirdLife, se hicieron pruebas para reducir la contaminación lumínica en puntos concretos de la isla de Tenerife, con resultados altamente positivos. Y ahora lo que se trata es, desde el Gobierno de Canarias, desde la posición que ahora ocupo, el poner sobre la mesa toda la instrumentación legal que de un gobierno podemos articular. Por suerte, los gobiernos podemos articular leyes, y una de las leyes que estamos impulsando dentro del ecosistema normativo es precisamente la Ley de Biodiversidad y Patrimonio Natural, o recursos naturales. Al final, es una ley que le va a dar la importancia que se merece a nuestra biodiversidad, a la protección de nuestras especies, a la defensa frente a otras especies exóticas con carácter invasor, pero que evidentemente en el caso concreto del proyecto que nos ocupa es extender con carácter de ley la protección de nuestros suelos, de nuestros cielos, y por lo tanto limitar la contaminación lumínica al conjunto de las 8 islas Canarias. Cuando hablamos de que ahora estamos en plena expansión de sustituir las luminarias actuales por luminarias LED menos contaminantes, la contaminación no solo se puede medir en contaminación atmosférica, en los gases de efecto invernadero que se asocia, sino también en el daño que se hace a otros elementos de nuestro entorno natural, que también es biodiversidad y que por lo tanto también tenemos que proteger. Y por lo tanto tenemos una asignatura pendiente en la reducción de la contaminación lumínica. Cada vez son más las especies de aves que se encuentran en serio peligro de desaparición de nuestro planeta. Canarias es un punto importante dentro de la protección de las aves. No solo por las que residen en ella, sino también por las que toman las Islas Canarias como puente de paso en sus procesos naturales migratorios. Y por lo tanto, tenemos esa asignatura pendiente a la hora de reducir esa contaminación lumínica. No solo por los efectos que pueda tener sobre el cambio climático, sino sobre todo también por los efectos muy positivos que puede tener en mejorar los ratios de recuperación y de protección de la población de la avifauna que tiene como punto de residencia el conjunto de la Macaronesia. Por lo tanto, este es un proyecto importante, un proyecto donde a tenor del orden del día se ve que no solo se va a hablar de las problemáticas que se asocian a la contaminación lumínica, sino que también se van a poner sobre la mesa propuestas para solventar ese problema que se pondrá en evidencia en la primera parte. Y esas propuestas les puedo garantizar que van a tener el apoyo decidido por parte del Gobierno de Canarias. La Ley de Biodiversidad y Recursos Naturales o Patrimonio Natural, que esperamos poder llevar a Consejo de Gobierno con una primera lectura a finales del año que viene, va a ser un hito importante. Y queremos que al finalizar este mandato tengamos ese ecosistema normativo compuesto por ley de cambio climático, donde se le da una importancia plena a la protección de la biodiversidad, ley de economía circular, ley de biodiversidad y recursos naturales, y después la cuarta de las leyes, la ley del suelo, que pasará a llamarse ley del territorio, porque precisamente lo que tiene que hacer esa ley es dar cobijo a las necesidades que las otras 3 leyes van a poner de manifiesto. De manera que empecemos ya a hablar de protección. Ya el debate sobre cómo crecer ha quedado atrás en el siglo XX y primera década del siglo XXI, por lo tanto, ya no se trata de crecer, sino se trata de recuperar la armonía natural que el ser humano tiene que tener con el resto de especies, animales que habitan en el planeta Tierra. Y en esa línea, jornadas como esta, las conclusiones que emanen de esta jornada y de este proyecto, tienen el compromiso de que serán muy bien recogidas por parte del Gobierno de Canarias, y es más, en la medida de nuestras posibilidades, recogeremos cuantos guantes se nos tiendan y con el objetivo de impulsarlas y de seguir poniendo soluciones a lo que actualmente son problemas. Por lo tanto, muchas gracias por la oportunidad que dan al Gobierno de Canarias de participar con esta breve intervención y animarles a seguir reiterando foros e iniciativas como esta y como otras muchas que están en la historia de Sobre BirdLife y sin las cuales, evidentemente, tendríamos una pata que cojearía en la acción protectora que por parte de todos los gobiernos tenemos que emprender.
Muchas gracias, consejero. Damos paso ahora a Isabel García Hernández, consejera insular del Área de Gestión del Medio Natural y Seguridad del Cabildo Insular de Tenerife.
Muy buenos días, gracias por invitarme a esta presentación y darles la enhorabuena por la organización de esta jornada que vienen a culminar una colaboración con Sobre BirdLife muy estrecha, muy productiva y muy interesante y que para el Cabildo de Tenerife pues es un orgullo ir de la mano con esta organización que tiene una dilatada experiencia y trayectoria en la defensa de las aves y de nuestra biodiversidad en general. Estas jornadas son importantes para estrechar estos lazos entre distintos organismos, entre distintas asociaciones y compartir experiencias que nos permiten avanzar en la solución y en la corrección de los impactos negativos que tiene pues, el desarrollo urbanístico, la iluminación nocturna del litoral, ¿no? y que está ocasionando pues, que las aves marinas caigan accidentadas en el territorio, ¿no? La solución a este problema desde el Cabildo de Tenerife se plantea como una planificación, una gestión que caminen de la mano tanto desde la parte territorial, para que cada vez este desarrollo urbanístico sea más respetuoso, sea más controlado, y también pues de la mano también de la gestión, ¿no? La gestión activa para que sea posible prestar auxilio a todas las aves marinas que se deslumbran y se desorientan y llegan a tierra, y cuando son capaces de emprender nuevamente el vuelo, aquí es donde la gestión es fundamental, y en esto pues el Cabildo de Tenerife está muy activo, ¿no? Desde esta área de gestión del medio natural trabajamos apoyando esta conservación de aves a través del Centro de Recuperación de Fauna de la Taonilla, y tenemos una campaña específica todos los años para la recogida de pollos de pardela, que cuenta con la colaboración también de muchas personas voluntarias, afortunadamente, que también se prestan a participar en esta acción, ¿no? El Centro de Recuperación de Fauna de la Taonilla se encarga de coordinar la recogida, recuperar y liberar a estos pollos durante la campaña, ¿no? Aquí nos coordinamos con las policías locales, con los ayuntamientos, y tenemos un buen porcentaje de éxito, porque de los 2.500 pollos de pardela que hemos recogido en esta última campaña, pues prácticamente la totalidad de las mismas fueron devueltas al mar, ¿no? Este año, lo que va de campaña, se calcula que han caído, pues también es una buena noticia, han caído 3 veces menos pollos de pardela que otros años, y esto pues tiene distintas explicaciones. Una de las explicaciones es que ha coincidido con la luna llena, justamente en este periodo, lo que hace que las pardelas pues tengan una guía natural, ¿no? para situarse y volar de una manera controlada, y pues también al mismo tiempo otro de los motivos ha sido, como no, pues el tema de la pandemia, del COVID-19, pues que hace que los hoteles y muchas infraestructuras turísticas estén sin luz, estén apagadas, y eso hace que la pardela pues haya tenido mayor suerte en este sentido, ¿no? No por esto estos datos deben hacernos que nos confiemos, y tenemos que seguir reflexionando de cómo mejorar todo este entorno para que la biodiversidad y la interrelación con el ser humano pues sean cada vez más beneficiosas para las aves y para la naturaleza en general, ¿no? Añadir, además, que los datos de esta última campaña deberían permitirnos racionalizar la iluminación de nuestros espacios, ya lo tenemos claro. Es intención de este Cabildo Insular también conveniar con los sectores hoteleros de los municipios de Adeje, de los municipios del sur de Tenerife, donde más caída de pardelas se están dando en los últimos años, para que los ayuntamientos contribuyan a bajar la intensidad lumínica de sus calles o de sus hoteles, intentar arrancar un compromiso. Teníamos previsto hacer este convenio este año 2020 para contribuir todos a esta labor, pero pues con el tema de la pandemia, pues efectivamente dejamos este convenio para más adelante, pero está claro que queremos seguir dando pasos firmes en bajar la intensidad lumínica de determinadas zonas donde está demostrado que es donde más pardelas caen de manera estrepitosa y con una mayor intensidad, y por tanto pues el Cabildo seguirá trabajando en esta línea para hacer que la pardela pues se conserve mejor, se accidenten menos, y por tanto pues contribuyamos todos a su recuperación y a su no extinción, ¿no? En definitiva, pues agradecerles a BirdLife el apoyo que dan a este Cabildo para acometer acciones de este tipo, y que siempre sabemos que están apoyando de manera continuada a las acciones que hace este Cabildo, y darles las gracias y la enhorabuena por estas jornadas, por esta participación, y que esta colaboración se extienda en el tiempo y podamos reeditarla y podamos seguir colaborando como lo hemos hecho hasta ahora, por el bien de la naturaleza, por el bien de la biodiversidad. Yo siempre digo que la presencia de aves es igual a salud, y tenemos que ir dando pasos en este sentido y seguir avanzando como lo hemos hecho hasta ahora. Muchísimas gracias a todos, y que tengan unas felices jornadas y que sean muy provechosas para todos los participantes en las mismas.
Muchas gracias, consejera. A continuación tiene la palabra Manuel Amador Jiménez, director de Medio Ambiente del Cabildo Insular de Gran Canaria.
Muchas gracias, Yarsi, muchas gracias a Sobre Life por la invitación que hace el Cabildo para la presentación de esta jornada. Muchas gracias también a los 14 socios, ¿no? Es un proyecto, cuando hay un número tan elevado de socios, no es un proyecto fácil de gestionar y yo creo que podemos estar muy satisfechos de cómo ha transcurrido el desarrollo de este proyecto y bueno, que está llegando a su fin, en el 2020 llegamos a su fin y esperemos que acciones similares o parecidas pudiéramos realizar en el futuro, porque creo que la contaminación lumínica está siendo un problema creciente, un problema que hay mayor sensibilidad, pero estamos atajándolo en una medida bastante pequeña, con lo cual todos los esfuerzos que hagamos en temas de contaminación lumínica será bienvenido. No solamente impide la observación de las estrellas y la observación del cielo a las personas, sino que también tiene incluso problemas para la salud de las personas. En entornos urbanos puede alterar el reloj biológico, puede modificar el sueño y la vigilia de las personas, puede generar trastornos afectivos y envejecimiento acelerado de las personas, pero posiblemente a la Consejería de Medio Ambiente lo más que le preocupa es la afección que pueden tener en la biodiversidad. Pues evidentemente nos afectan a los invertebrados, que son en la cadena trófica, es el elemento principal para alimentar pues a aves, y no solamente el alimento de aves, sino que también para la polinización de plantas. Si los invertebrados empiezan a dejar de hacer su actividad, pues evidentemente la floración muchas de las especies de flora pues se quedan pues sin fertilizar, sin fecundar y tienen problemas. Muchos de los insectos son de hábitos nocturnos y son deslumbrados, con lo cual o bien son depredados más fácilmente o bien sufren muertes por agotamiento. Empiezan a moverse alrededor de la luz y dejan de hacer sus funciones tanto de fertilización como de alimentar, así es el ciclo de la vida, pues a las aves, ¿no? o a otros vertebrados que pueden estar como reptiles o etcétera, ¿no? Pueden colocar los huevos en lugares inadecuados, con lo cual también se pierde una parte de la población de estos invertebrados. Evidentemente también afectan a las aves y a las tortugas. Las aves y las tortugas se fían mucho, bueno, pues no sabemos todavía muy bien, o si bien del reflejo de las estrellas o bien del reflejo de la luna, para una referencia de navegación. La contaminación lumínica le impide y hay una atracción mortal a la luz, se agotan en vuelos circulares, hay colisiones pues porque se confunden, etcétera. Es decir, que está habiendo un impacto muy importante en las aves, y en las tortugas ocurre algo similar. En vez de ir al mar, a donde tienen que ir, incluso van a donde está el reflejo de la luz. Y bueno, y hay experiencias en Costa Rica o en algunos lugares que en vez de ir al mar, pues van a la avenida marítima, donde está iluminada, pues están confusas por el tema de la luz. No solamente afecta a las pardelas, que bueno, que yo creo que es el ejemplo de referencia y tal, y a las tortugas, sino también nos afectan a las aves diurnas. Las aves diurnas alargan su ciclo vital, con lo cual en algunas ocasiones pues tienen dificultades para descansar, y a las aves nocturnas pues se les dificulta pues su posibilidad de cazar, porque son mucho más visibles, y entonces tienen más dificultades para alimentarse. Es decir, que es un problema complejo. Evidentemente al ser humano casi le estamos diciendo que se le impide ver el cielo, que evidentemente es cierto, o incluso tienen problemas vitales, pero a la Consejería de Medio Ambiente del Cabildo Gran Canaria, pues lo que le preocupa es el tema de la biodiversidad. Las administraciones públicas deberían preservar al máximo las condiciones naturales de las horas nocturnas en beneficio de la flora y la fauna y los ecosistemas en general. Eso está recogido en la Ley 42/2007, la Ley de Biodiversidad, y yo creo que las administraciones deberíamos hacer bastante más de lo que estamos haciendo, ¿no? Hay que prevenir, minimizar y corregir los efectos de la contaminación lumínica en el cielo nocturno, y en particular también para los observatorios astronómicos, que tanta investigación científica hay que dependen de que haya unos cielos oscuros, unos cielos donde se pueda ver el cielo, ¿no? Yo simplemente agradecer a García Acosta la invitación, a Sobre Life, y que esta jornada pues sean fructíferas. Yo estuve en Madeira pues en octubre del año 2019, aprendí muchísimo, y yo creo que tienen la oportunidad también de, bueno, ya que estamos concluyendo este proyecto, sacar unas reflexiones para el futuro y trabajar de forma conjunta en lo que nos importa en este proyecto, que es intentar reducir la contaminación lumínica. Muchas gracias a todos y que sean fructíferas estas jornadas.
Gracias, Manuel. Seguimos con Domingos Leitao, director ejecutivo de la Sociedade Portuguesa para el Estudio de las Aves. Tiene la palabra Domingos Leitao.
Olá a todos. A SPEA é uma organização não governamental de ambiente cuja missão é esta de trabalhar para o estudo e proteção das aves e dos seus habitats, promovendo um desenvolvimento que garanta a viabilidade do património natural para usufruto de nós outros e das gerações futuras. Sabemos que as aves marinhas são um dos grupos de aves mais ameaçadas do mundo inteiro, com mais espécies à beira da extinção e outras que enfrentam declínios populacionais muito acentuados. As razões para estes factos são muitas e relacionadas com o modo irresponsável com que a humanidade trata o oceano e a exploração excessiva dos recursos marinhos. As aves marinhas são afetadas nas ilhas e nas costas onde se reproduzem pela introdução de espécies invasoras, destruição de habitat e pela perturbação causada por atividades humanas. E as aves marinhas são também afetadas no mar pelo excesso de pesca, que afeta o seu alimento, pela mortalidade acidental em artes de pesca, pelos plásticos que lançamos todos os dias no oceano e também são muito afetadas pelas alterações climáticas. Eu penso que somos todos unânimes em dizer que não queremos um oceano, não queremos os mares sem aves marinhas. Sem aves marinhas, não. O que seria, por exemplo, dos navegadores portugueses e castelhanos do século XIV e XV, se não tivessem as aves marinhas a ajudar a encontrar o caminho e descoberta de novas ilhas e novas zonas costeiras, dos pescadores que ao longo dos tempos sempre se serviram dos movimentos das aves marinhas como indicadores de bons pesqueiros, e dos serviços de ecossistemas que sabemos que as grandes colónias de aves marinhas prestam no ciclo dos nutrientes e na manutenção da biodiversidade nas costas marinhas continentais e das zonas insulares. Por isso, com o projeto Luminaves foi muito importante porque permitiu conhecer e minimizar e reduzir o impacto da iluminação pública artificial nas aves marinhas. Sabemos hoje, graças ao projeto Luminaves, os locais nas ilhas dos Açores, Madeira e Canárias e as espécies de aves marinhas que são mais afetadas pelo excesso de luz artificial. Temos hoje também campanhas bem organizadas e infraestruturas mais adequadas ao salvamento dos milhos de aves afetadas por este problema. Salvamos milhares de aves todos os anos, por exemplo, só nos Açores são quase 10 mil os cagarros ou pardelas cinzentas que são salvos todos os anos nas campanhas de salvamento de aves marinhas. Para a SPEA é muito importante toda a informação recolhida e toda a capacidade implementada pela parceria Luminaves. Também sabemos que muitas aves ficaram por salvar, isso queremos que é o mais importante. E por isso neste contexto sabemos que temos que resolver o problema mais na sua raiz e não ficarmos apenas por minimizar o seu impacto. Por isso foram muito importantes no âmbito do Luminaves os primeiros passos dados para a solução deste problema na sua origem, para a solução dos problemas de excesso de iluminação pública na sua origem. Foram as decisões pioneiras tomadas por alguns municípios, por exemplo, o município do Corvo nos Açores, o município de Santa Cruz na Madeira e outros também, de apagar ou reduzir substancialmente a luz pública em determinados locais e em determinados dias e horas que salvaram milhares de aves, evitando que fossem atraídas e desviadas das suas rotas normais. Estamos em crer que o exemplo destes municípios que estiveram fortemente envolvidos com Luminaves será seguido e aperfeiçoado por outros, para assim resolvermos de uma forma mais eficaz e na fonte os impactos do excesso de poluição luminosa nas aves marinhas. E também, por que não dizê-lo, contribuir para a saúde dos cidadãos, porque o excesso de luz causa também inúmeros problemas nas pessoas. E contribuir para a melhoria das finanças públicas, porque gastar energia elétrica em iluminação excessiva não é sustentável, não é benéfico para nenhum município. Portanto, a SPEA está disponível para continuar a trabalhar em parcerias futuras com entidades públicas e privadas, em projetos de disseminação dos resultados ilumináveis e em projetos de aperfeiçoamento destas medidas de redução e prevenção ensaiadas no projeto Lumináveis. Para terminar, gostaria de dar os parabéns aos parceiros do projeto Lumináveis, à BirdLife, ao Governo dos Açores, ao Instituto das Florestas e Conservação da Natureza da Madeira e à SPEA, bem como todas as outras entidades e pessoas que estiveram envolvidas neste projeto e no trabalho realizado. E desejar a todos vós um webinar muy proveitoso y a todos muito obrigado.
Gracias, Domingo. A continuación, con el cierre de la apertura de las jornadas, Asunción Ruiz, directora ejecutiva de la Sociedad Española de Ornitología.
Muchísimas gracias, García. Como directora ejecutiva de Sobre BirdLife, la organización decana en España, en esta difícil ruta de conservar la biodiversidad, es un verdadero placer estar hoy aquí en la puesta de largo de un proyecto que venía a estudiar una amenaza desconocida, la contaminación lumínica, frente a un grupo de aves, el más amenazado del mundo, las aves marinas. Me gustaría empezar diciendo muchísimas gracias a los 14 socios que han formado parte de este gran trabajo que hoy culminamos con estas jornadas, y darle las gracias a todos los científicos que van a formar parte del primer bloque, que es el de las evidencias de ciencia que muestran cómo la contaminación lumínica es una amenaza para las aves marinas, científicos que proceden de Australia, de Reino Unido, de Alemania, de Portugal, de Azores, o sea, en Portugal tanto de Azores como de Madeira, de España e incluso de Estados Unidos, y también darle unas de verdad sinceras gracias a todos aquellos que van a presentar en el segundo bloque de estas jornadas los casos prácticos y las lecciones aprendidas. Para Sobre BirdLife, como organización de conservación que usa las aves como bandera y como termómetro del estado de salud de nuestros medios, es un verdadero honor estar aquí, formar parte de este encuentro y decir que, por supuesto, Sobre BirdLife no solo y exclusivamente trabaja con lo que hoy se presenta o se analiza, que es la contaminación lumínica, ¿no? Sino que Sobre BirdLife ha trabajado en la conservación de este grupo de aves en todos sus frentes, ¿no? Desde la captura accidental de aves marinas por artes de pesca a la propia contaminación del mar. Pero quizá hoy es un día relevante porque sí que ponemos encima de la mesa las últimas evidencias y casos prácticos y de mejora para acabar con esta amenaza que es la contaminación lumínica. No puedo dejar de mencionar a nuestro gran partner en este proyecto, que es el partner de BirdLife en Portugal, de la SPEA, porque juntos hemos recorrido todo este camino. Y como directora ejecutiva yo creo que tengo muy poquito que añadir. Os deseo que de verdad paséis unas jornadas muy fructíferas por el bien de las aves marinas y por el bien de la biodiversidad, que hoy, más que nunca, cuando estamos sufriendo las tristes consecuencias de esta pandemia, sabemos que conservar la biodiversidad es conservar nuestra calidad de vida y nuestro futuro. Muchísimas gracias.
Muchas gracias a Asunción y al resto de participantes en esta apertura, en representación del Gobierno de Canarias, de los cabildos de Gran Canaria y Tenerife, de la Sociedad para el Estudio de las Aves, de la Sociedad Portuguesa para el Estudio de las Aves y de Sobre BirdLife, estos dos últimos organizadores de esta jornada. Es el momento ahora de poner sobre la mesa el contexto. Si me disculpan, voy a compartir pantalla. Aquí está. Listo. Bueno, como iba diciendo, estas jornadas que se van a desarrollar entre hoy martes y pasado mañana, jueves 26 de noviembre, se pueden seguir en el canal de YouTube de Sobre BirdLife. Son unas jornadas que se organizan en el marco del proyecto Lumínica y Aves, del que hablaré un poco más adelante. Estas jornadas pretenden convertirse en un punto de encuentro entre investigadores, sociedad civil y responsables de la toma de decisión en cuanto a la gestión de los recursos naturales. Son una ocasión, o pretenden ser una ocasión, para ponernos al día sobre el estado del conocimiento en cuanto a contaminación lumínica, una amenaza extraordinariamente grave y a la vez desconocida, como veremos durante los próximos días. Para ello vamos a utilizar en gran medida a las aves marinas como testigos del impacto de esta amenaza, aunque no como única víctima, desde luego. También es la ocasión de poner sobre la mesa la experiencia de otros lugares que se enfrentan al mismo problema para tratar de identificar posibles soluciones que sean replicables. Desde el punto de vista organizativo, después de esta apertura, las jornadas se van a desarrollar en dos bloques. Un primer bloque sobre el fenómeno y sus impactos y un segundo bloque sobre casos prácticos, como acabo de comentar. Previo al primer bloque, tendremos una intervención de P. Barcos, responsable del programa marino de Sobre BirdLife, que nos ayudará a ponernos pues, en contexto sobre aves marinas, digamos que es el grupo animal sobre el que giran estas jornadas, aunque como he comentado, evidentemente la contaminación lumínica afecta a los ecosistemas en su conjunto. Sobre el primer bloque tendremos a los doctores Franz Holker, Teresa Jones, Svenja Tidau, Travis Longcore y Ayrán Rodríguez. Todos ellos investigadores de referencia en sus campos de estudio. El segundo bloque contaremos con participantes de Canarias, de Azores, de Phillip Island en Australia y de Madeira, tal como se puede ver en el programa. Es importante destacar que por la situación sanitaria nos hemos visto obligados a organizar estas jornadas a distancia, no era nuestra intención inicial, y que además por motivos técnicos hemos decidido pregrabar las intervenciones. En cualquier caso, al final de cada intervención, los ponentes estarán disponibles durante 10 minutos, un cuarto de hora aproximadamente, para resolver las dudas que les hayan podido surgir. Es decir, se puedan plantear todas las cuestiones que se deseen en el chat. Como comentaba al principio, estas jornadas se organizan en el marco del proyecto Lumínica y Aves. Lumínica y Aves es el acrónimo. El título real del proyecto es Contaminación Lumínica y Conservación en los archipiélagos de la Macaronesia, reduciendo los efectos nocivos de la luz artificial sobre las poblaciones de aves marinas. Bueno, es un proyecto que comenzó en 2019 y que termina este año, en 2020, financiado por la Unión Europea a través del programa de cooperación territorial Interreg-MAC 2014-2020. Es un proyecto que cuenta con 13 socios de esos archipiélagos, Azores, Madeira y Canarias. En Canarias serían socios la Consejería de Transición Ecológica, Lucha contra el Cambio Climático y Planificación Territorial del Gobierno de Canarias, el propio Sobre BirdLife como líder del proyecto, además del Instituto de Astrofísica de Canarias y de los cabildos de Gran Canaria, Tenerife y Fuerteventura. En Madeira tendríamos a la Sociedad para el Estudio de las Aves, SPEA, que también organiza estas jornadas, al Instituto Forestal y de Conservación de la Naturaleza y a la empresa de electricidad de Madeira. Y en el caso de Azores, pues a la Dirección Regional de Asuntos del Mar, al Fondo Regional para la Ciencia y la Tecnología y a la Cámara Municipal de Corvo, así como a la eléctrica de las Azores. Este proyecto parte de un problema común en la Macaronesia, que es el impacto de la contaminación lumínica en las aves marinas, y se articula en torno a 3 ejes: conocimiento y conservación, gobernanza y divulgación. Muy brevemente, en cuanto al conocimiento, la verdad es que se ha hecho un esfuerzo muy importante durante 3 años. Se han estudiado parámetros biológicos en distintas colonias, en el caso de Canarias en Tenerife, donde se ha llegado a visitar unos 2000 nidos durante el par de la Cenicienta y Peter de Bulwer durante este periodo de 3 años. También en Madeira se ha realizado un censo de par de la Cenicienta en 2017 y 2018. En Azores se ha estimado abundancia y se han realizado otras locaciones de pardelas a zonas libres de impacto de depredación y contaminación lumínica. Se ha realizado un mapeo de contaminación en los 3 archipiélagos, utilizando datos satelitales e información sobre siniestralidad obtenida de las distintas campañas de rescate que se ponen en marcha. Bueno, esas son algunas de las numerosas acciones que se han realizado. En cuanto a gobernanza, el proyecto ha apoyado a una mejora en la toma de datos de las campañas de rescate de aves delumbradas y a la estandarización de los protocolos de tratamiento de estas aves. Además, se ha elaborado de manera participativa una estrategia y un plan de acción sobre contaminación lumínica en la Macaronesia, que presentará durante estas jornadas Azucena de la Cruz, que es coordinadora de SPEA en Azores. El último de los ejes en los que hemos trabajado es el de sensibilización y divulgación. Aquí se ha hecho también un esfuerzo muy notable, elaborando distintos materiales divulgativos, como un corto de animación que se puede ver también en YouTube, tecleando esos pardelas, dirigido, no exclusivamente dirigido a niños, pero con un enfoque orientado a este tramo de edad. Se ha elaborado una unidad didáctica online y se ha organizado un buen número de actividades en las que han participado pues miles de personas, ¿no?, en los 3 archipiélagos. Por último, agradecer nuevamente a todos los participantes y a continuación les dejamos con P. Barcos, responsable del programa marino de Sobre BirdLife, que tratará de poner sobre la mesa, de contarles un poco sobre aves marinas y las amenazas que las afectan, para que tengamos un punto de partida con el que comprender mejor el resto de intervenciones.
Muchas gracias, Yarci. Pues yo voy a hablar un poco del contexto, no del tema concreto de las aves marinas, o sea, de las aves marinas y las luces, sino dar un contexto más general a las aves marinas y su problemática, y un poco del trabajo que hacemos en SEO en este sentido, más allá del proyecto Luminaves. Pues las aves marinas son depredadores del medio marino, o sea, se encuentran en los escalafones más altos de las cadenas tróficas marinas, y como tales pues integran todo lo que pasa en el ecosistema. En los niveles inferiores, pues a través de la cadena trófica acaban integrando ese conocimiento lo que está pasando. Eso las convierte en buenos indicadores del estado de conservación del medio, pero también las convierte en especies muy sensibles a todo tipo de amenazas. Además, son especialmente sensibles a aquellas amenazas que causen mortalidad directa, porque se trata de un grupo con una longevidad elevada. La mayoría de especies pues, suelen tener vidas de varias décadas, y al mismo tiempo pues, su reproducción es más bien lenta. Muchas especies pues, ponen un solo huevo al año, no crían todos los años, empiezan a criar cuando ya tienen varios años de edad, y eso hace que si aumentamos la mortalidad se reduce esta esperanza de vida, pero no tienen capacidad de compensarlo porque no pueden incrementar las tasas de reproducción. Al mismo tiempo, pues tienen una gran movilidad, alternan entre tierra para criar y el mar abierto para alimentarse, pueden recorrer miles de kilómetros y eso hace que encuentren amenazas en diferentes momentos de su ciclo vital y por lo tanto pues que estén expuestas por varios lados. Y bueno, hay que tener en cuenta pues que el medio marino y costero son ambientes muy humanizados en los cuales pues es eso, hay una intensa presión humana y por lo tanto las amenazas pueden ser diversas. Eso hace que las aves marinas del total de aves sean de los grupos más amenazados que hay. Podéis ver aquí pues, que a la izquierda estaría la columna correspondiente al conjunto de aves mundial, que son cerca de 11.000 especies, y podéis ver pues, que las que están más amenazadas, que son pues, los colores estos rojo en peligro crítico, naranja en peligro, amarillo vulnerable, o se considera este verde más claro casi amenazada, según las categorías de la Unión Internacional para la Conservación de la Naturaleza. Pues bueno, el total de aves pues tiene pues poco más de un 20% de especies entre amenazadas y casi amenazadas, y en cambio en las aves marinas nos vamos casi a la mitad. Además, si nos fijamos especialmente en las pelágicas, como son los procelariformes, que son pardelas, petreles y paíños, que es un grupo que tiene especial relevancia en la Macaronesia, pues podemos ver que la proporción de especies amenazadas es aún mayor, con varias especies críticamente amenazadas, es decir, en verdadero peligro de extinción. Mientras que las costeras, pues no estarían tan afectadas. Costeras se entiende más especies tipo gaviotas, charranes, cormoranes y otros. Más allá de estas categorías de amenaza, un estudio reciente revelaba que en 60 años, desde el año 1950 hasta 2010, las poblaciones globales de aves marinas habían caído en un 70%. Es decir, la abundancia la abundancia total de aves marinas había caído en un 70%, lo cual es un declive muy considerable y que concuerda pues, con esta situación de amenaza generalizada. Dentro de este contexto, pues recordar que a nivel de España tenemos una diversidad de especies de aves marinas muy, muy grande, tenemos diferentes regiones biogeográficas y por lo tanto pues da pie a especies muy diversas. Y en el ámbito de Canarias, pues destacar especialmente, como comentaba, el grupo de los procelariformes, que son básicamente pues, las pardelas, como la más característica y emblemática es la pardela cenicienta, que tenéis aquí marcada con un círculo rojo. Es la especie más común de las que crían en el archipiélago, tanto en Canarias como en Madeira y Azores. Luego tenemos otras especies de pardelas como la pardela chica y la pardela pichoneta, que están bastante más amenazadas. Y luego tenemos varias especies de paíños, así como aquí a la derecha de todo un petrel, el petrel de Bulwer. Todos ellos merecedores de atención por ser especies sensibles y todos ellos sensibles en particular al tema de las luces. Es lo que nos trae hoy aquí. Más allá del tema de las luces, pues comentar un poco las amenazas generales que tiene el grupo, destacando en especial aquellas que afectan, bueno, que causan la mortalidad directa de los adultos, que como comentaba al principio, pues es un parámetro demográfico muy sensible. Y tenemos pues la depredación por parte de especies introducidas, de ratas, gatos, en sus colonias de cría. Es decir, muchas de estas aves pues, crían en islas como la Macaronesia, donde no había depredadores terrestres de forma natural y llegaron con el hombre, y esto pues, ha representado una presión sobre especies que no tenían ningún tipo de defensa contra ellos. Luego también la captura accidental de aves marinas en artes de pesca, que es un tema que tampoco es intencionado, pero que existe, también tiene un impacto muy importante sobre muchas especies. Y luego pues tenemos otros temas que pueden ser más o menos importantes según la especie y según la zona, como es la contaminación, inclusive la lumínica, el cambio climático, etc. Aquí, bueno, simplemente una gráfica de un trabajo de revisión en el que intentaban cuantificar el grado de amenaza de diferentes especies según el tipo de presión, y veíamos que las especies invasoras o introducidas, la depredación que comentaba, pues es el principal problema en términos de especies afectadas. La captura accidental sería el segundo factor. Y luego aquí tenemos que la contaminación lumínica queda un poco más alejado, pero hay que tener en cuenta que a lo mejor a nivel de todas las aves marinas no es un problema tan importante, pero a nivel de ciertas especies sí que lo es, y es el caso, por ejemplo, de muchos de las pardelas y paíños que crían en la Macaronesia. Y ya solo para cerrar, pues un poco una pincelada al trabajo que hacemos en el ámbito marino en Sobre BirdLife. Bueno, aquí hay un pequeño listado, pero los comento con un poco más de detalle. O sea, para empezar, es muy importante tener programas de seguimiento que nos permitan estudiar y entender lo que está pasando y poder tomar las decisiones acertadas con conocimiento de causa. A nivel de programas de seguimiento, pues es importante hacer un seguimiento de la reproducción en las colonias de cría, entender su demografía. Hacemos trabajos, por ejemplo, de censos en el mar y de marcajes para conocer también la ecología en el mar. Y, bueno, pues diferentes programas de voluntariado que también aportan información diversa. Y a nivel de otros aspectos de conservación, pues se ha tenido un papel destacado junto con SPEA en la identificación de áreas importantes para las aves a nivel marino y su ulterior protección mediante la Red Natura 2000 como zonas de especial protección para las aves, como CEPA. Aquí tenéis los resultados de un proyecto que tuvimos entre 2004 y 2009, tanto SEO como SPEA, y en el que se identificaron pues, varias zonas candidatas a ser protegidas para las aves marinas en el mar. Y esto sería, a nivel de España, un resultado de lo que dio pie este tipo de inventario, y es a proteger una serie de zonas. Aquí, la verdad es que hay un mapa de Red Natura 2000 que incluye tanto las cepa como los LIC, que serían para otras especies o para hábitats. Pero bueno, digamos que en 2014 se consiguió una protección de estos espacios marinos, y ahora en lo que se está trabajando, especialmente a través del proyecto Intemares, es en la consolidación de estos espacios, en acabar de abordar huecos, lagunas de conocimiento y de elaborar planes de gestión, así como modelos de gobernanza de estos espacios. En SEO, un aspecto que trabajamos mucho, por lo que hemos visto del problema de las capturas accidentales, es pues, trabajar con pescadores para buscar soluciones que estén consensuadas por todos. Entonces, trabajamos tanto con pescadores sobre el terreno, evaluando el problema y buscando soluciones, como a nivel político para intentar captar la atención de los políticos. Y bueno, estamos teniendo algunos proyectos actualmente con el Fondo Europeo Marítimo y de Pesca, y solo recordar eso, que el enfoque es colaborativo. Se trata de, bueno, las capturas accidentales no las quieren los pescadores, y lo que queremos es trabajar con ellos para hacerles ver que el problema no es solo suyo, sino también de las aves y del ecosistema, y buscar soluciones que, un poco pues, como lluvia de ideas entre unos y otros, pues es más fácil encontrar qué soluciones pueden ser factibles. También trabajamos con depredadores. En este caso, destacar el trabajo que estamos haciendo en Menorca, donde una colonia de pardela balear, la especie más amenazada de ave marina de Europa, pues está amenazada por la presencia de varios depredadores, inclusive gatos, que son los que tienen mayor incidencia. Entonces, pues se está trabajando se hace un seguimiento de la reproducción, se está facilitando la reproducción en cajas nido, se hace un seguimiento de depredadores con cámaras de trampeo, y la idea es que se instale esta colonia está en un istmo, o sea, en una península, perdón, y la idea es instalar una barrera en el istmo, una barrera antidepredadores que permita evitar el acceso de depredadores y luego pues hacer algún tipo de programa para asegurar que no queda ninguno dentro tampoco. Bueno, tema de contaminación, creo que aquí destacar el tema de la contaminación lumínica, pero de eso se va a hablar hoy largo y tendido y por lo tanto no me alargo, aunque bueno, tocamos también otros temas como vertidos de hidrocarburos y demás. Y solo como notas finales, creo que está bien un poco como reflexión, recordar que es esencial para cualquier tipo de actuación contar con buenos datos, con buena información y que esté bien analizada, bien tratada, para hacer una buena diagnosis y saber realmente lo que hace falta, cómo hace falta actuar. Es muy importante identificar bien los problemas y actuar cuando y donde sea necesario, no sobregestionar, no querer actuar cuando no hace falta. No despistar con problemas inabordables. Aquí, pues simplemente, digamos que a cada nivel de gestión pues hay unas ciertas responsabilidades y a veces nos encontramos pues que el gestor local que poco puede hacer sobre el gran problema de la contaminación marina por plásticos, por ejemplo, evidentemente se puede hacer pedagogía, se pueden hacer limpiezas, pero eso no va a solucionar el problema, hay que actuar a un nivel mucho más global. Entonces, no despistar diciendo que estos problemas son los más importantes y olvidarse de los que podemos gestionar a nivel local y realmente ser valientes y gestionar lo que se debe gestionar, como puede ser el tema de luces, como puede ser el tema de depredadores, como puede ser el tema de pesca, que requieren de un enfoque mucho más local. Y bueno, recordar o cerrar con insistir en la idea de que para cualquier actuación es muy importante contar con todos los interesados o con todos los implicados, afectados, con lo cual aseguramos, hoy por lo menos minimizamos los malos entendidos y optimizamos la eficacia de cualquier actuación. Y con esto acabaría. Muchas gracias.
Muy buenos días. Frank es nuestro primer ponente de este workshop y voy a hablar en inglés, puesto que no va a haber comunicación con él. Hi Frank, how are you?
Hi, very good, nice to meet you.
Nice to meet you too. It's my pleasure having Frank involved in this workshop. Before starting with his presentation, I would like to introduce him to all of you. Frank is a biologist and he did his doctoral thesis in 1999 at the University of Hamburg. Since 2008, he is a senior researcher and group director at the Leibniz Institute of Freshwater Ecology and Inland Fisheries, the IGV in Berlin. He has been director of the Ecology department of the IGV from 2012 to 2017. He was the researcher in charge of the coast action Loss of the Night from 2010 to 2014. That coast action was a network that allowed contact and collaboration of European scientists from 18 countries. That was a really important action cost to our issue of light pollution. He also has directed the Illuminating Lake Ecosystem project, and he has published many research papers on the impact of light pollution and on biodiversity. And today he will talk about light pollution and obviously biodiversity. Frank, up to you. It's all your time. Thanks.
Yeah, thanks a lot, Ayran, for the nice introduction. And I will talk today about light pollution as a biodiversity threat. And I would like to start with this figure, which shows the Earth. And there is also the problem, because life is rhythm. Since billions of years, the Earth rotates around its axis every 24 hours, and it orbits the Sun every 365 days. So many processes in nature are rhythmic. Not only light, it's also temperature, other biotic processes, and also biotic processes that are directly connected to this. And of course, most organisms have evolved internal clocks controlled by day, night, and seasonal cycles. So if you talk about light pollution, you have to think about the night. And night is half of the story. On Earth, on half of the Earth, there's always night. And that is the reason why that a high percentage of organisms are nocturnal. 30% of vertebrates and more than 60% of invertebrates are nocturnal. They have adapted to the extremely low light situations of the night by evolving and developing low light sensors, for instance. And many body functions become rhythmic because of these changes of day and night: sleep, wake, performance, blood pressure, heart frequency, body temperature, digestive activities, and hormones. And this is not only true for humans. Here it is quite well understood already. It is also the case for other mammals, for plants, and even for microorganisms. Humans are the only species that are able to turn on and off the light wherever they want to do this. And they do it since a few decades to transport, to travel from point A to B on land, on water, to work during the night, to run, so to say, the 24/7 society. But by these activities, by using light at night, they completely transform nocturnal nightscapes during a time where humans, as a diurnal organisms, have adapted over millions of years to rest at night. And because many processes, physiological processes like repair processes, regeneration processes, are taken place during the night. So since the invention of light, artificial light increased dramatically. So in recent decades, it was there was an increase of global average light emissions of 3 to 6% during the second half of the 20th centuries. And in a study that was a few years published ago, over a time period of from 2012 to 2016, we saw also an increase of 22.2% per year in light levels, but also an increase in the areas that are illuminated. And the problem is, light has been introduced in places, times, and intensities at which it does not naturally occur. And many organisms have had no really chance to adapt to this new situation. I would like to start with vertebrates, and mainly with physiological aspects in vertebrates. And as I told you, 30% of the vertebrates are nocturnal, and it seems that younger groups, vertebrate groups, evolved more and more into the night age, with the exception of the amphibians, maybe. And I would like to present you the results of a study that was just published by us. It was about light pollution and melatonin production. Melatonin is a night hormone. So many organisms produce this night hormone, not only vertebrates, also other animals, even plants can produce it. And it fulfills a very important role. It informs cells and organs in the body, which are blind for the environment, of course, about the time of the day. And normally, for us, for instance, we produce melatonin during the night and suppress the production during the day. So it's quite clear that melatonin level in the blood is informing all different organs in the body about the time of the day, and they can adjust the processes. Night processes, physiological and behavioral process will take place during the night, and day processes during the day. And if this is mixed because the differences are no longer clear, then we already know that can result in many problems. But I would like to start with a natural light situation. So in the Canary Islands, for instance, during a nice summer day, you can reach levels of up to 120 lux on the ground. Twilight starts below 800 lux. The full moon can produce 0.3 lux. This is a really exceptional high value. Most times it's not more than 0.1 or 2 lux. And starlight is producing 0.001 lux. Light pollution now is polluting this kind of natural light. You can have outdoor lighting levels, direct light by street lights, other lights, security lights, up to almost the twilight levels. And as you see here, sky glow can be even higher than the light levels produced by the full moon. And here you see now the different melatonin suppression levels that we found in the literature. So for this, we searched for studies working on melatonin and light pollution and found around 1,700 studies, but only 75 of them were really light pollution studies. It means they during the experiments exposed the animals to bright light levels, daylight like levels during the day, and low light levels during the night. And what we found is, for instance, extremely high sensitivity of some fish species, which started to suppress the melatonin production, the night hormone production, at values of 0.01 lux, which is enormous. It's extremely dark value. It's almost going in these lower sky glow values that have been documented at different places. For birds, it might be interesting for you, is the lowest threshold that we found, reliable threshold, 0.3 lux. It's similar to the light of the maximum full moon, but we're not able to find, for instance, studies with petrels or other seabirds for these studies. Rodents seem to be quite vulnerable as well, with also sky glow levels that are able to suppress melatonin suppression. And in ungulates, it's 2.3. Humans, we found the lowest values for very sensitive humans at 6 lux. This is the number for really almost monochromatic blue light. And because melanopsin, this special circadian photoreceptor, is very sensitive to blue light, it's clear that such a low amount of light will produce a suppression of light, of melatonin production. The interesting thing now with these studies is that we found with increasing number of studies lower thresholds. And this may have several reasons. The methods are becoming better to test this, and people start to test for even these low light levels since only a few years. And we have to expect that for other groups, there will be also lower light levels found soon. Humans are here the exception again. Here the 6 lux reported for humans is more this exceptional monochromatic light. But of course, with humans, it's more difficult to run, for instance, lab experiments due to ethical reasons, of course. Okay, I would like to continue now with insects, now more focusing on behavioral aspects. Insects, yeah, half of the insects are nocturnal, and similar to the vertebrates, they are also adapted to this nocturnal niche by developing low light sensors. And these low light sensors can become easily stressed by such a street light, for instance, because they are not prepared to perceive such differences in light levels. Some insects are blind for more than 1 hour until they are able to use the visual information around for their environment. Within this 1 hour, they are blind for their environment. Some other insects, they have no chance. They are completely disoriented and exhausted after a while. And many insects show a clear positive phototaxis. And we are talking now in ecology also about a vacuum cleaner effect, because these vacuum cleaners attract insects from habitats nearby, and many of these insects have no chance to get back to these habitats or to travel to other habitats. There are some profiteers, some bad species are taking advantage of this new situations, but we know also, well, maybe everybody knows, have seen this high amount of spiders near a street lamp. And on a normal natural conditions, you would never find them in such a high density. And these predators are taking advantage of this high numbers of disoriented insects like a buffet. It's a very easy prey for them. To investigate how this is impacting insects in an ecosystem context, we run since 2012 an experimental field site. We have different field sites like this one, the kind of matrix of street lights in a distance of 20 meters from each other. We have several rows of lights, and we installed flight intercept traps, bottom pitfall traps and emergence traps to catch, for instance, insects that are aquatic insects that have an aquatic larval stage and then emerge as an adult flying insect. And what we found was that the emergence, the production of insects from the water system is increasing during the summer due to artificial light, due to street lights near the water surface. We also see that in a vacuum cleaner effect, aquatic insects are in a higher number now attracted to street lights near the shoreline. And it's a kind of ecological trap, especially for these aquatic insects, because many of them will have no chance to go back to these systems to lay eggs or to do other activities. And what we also see then, as a result, that there's an increase of the flux of aquatic insects into the terrestrial system. An increase of aquatic insects, but also of terrestrial organic matter, so to say. And what we also see that there's a cascade effect on terrestrial predators. There are many predators on the ground, on the bottom dwelling predators, that are able to take advantage of these new situations. Harvestmen, beetles, spiders, and the dietary composition of these predators is significantly affected. So artificial light at night is not only a nocturnal attractive or repulsive stimulus, it also affects aquatic terrestrial food web interactions. In the same system, we also investigated how microbial communities are impacted. We investigated here, for instance, sediment microbial communities during the night, which are important food source for insects, for many insect larvae living in these aquatic systems. And normally, under natural conditions, there's no photosynthesis during the night, so the net ecosystem production is almost zero, but the community respiration of these microorganisms, like microbial communities, is quite high. So net ecosystem production is normally lower than the community respiration. After we have illuminated the whole system for more than 1 year, it took quite a while, it was not an immediate effect. Then we saw that, the summer and winter communities, which were under natural conditions significantly differently from each other, were no longer, or we were no longer to disentangle them. There's no clear, so the temporal structure more or less is kind of impacted by light at night. And we put some of these samples into the lab, we transported them to the lab and exposed them to strong street lights, 70 lux. But the surprising thing was that now some of these microbial communities were able to run photosynthesis, and the native ecosystem production in some of these sediment samples were bigger than the community respiration. And this means photosynthesis during the night has happened never before during the evolution on Earth. This is a really new ecosystem situation induced by light at night. And of course, in this case, it is a kind of nocturnal thing, but it has to be tested if this is also takes place in other ecosystems as well. If you now position these vacuum cleaners, so street lights in a row, which is a normal situation for a typical street in a city, for instance, then this can result in a migration barrier, because many of these insects are still attracted to the lights and waste a lot of time and energy to pass these barriers. We also investigated this effect, the migration, the barrier effect in our field sites. This is from an airplane, a photo. And we tested the hypothesis, if there would be no effect of light pollution on the samples of flying insects, then these samples should be always the same. But this was not the case. Over several years, we found that the central traps collected less insects compared to the corner traps and the wing traps in this light field. And based on this, we calculated an attraction radius for moths, for instance, which was about 23 meters. 23 meters sounds not really big, huge. But if you consider, for instance, the situation of an urban area like here in Berlin, where you find a net of illuminated light corridors, and if you consider that the distance between lampposts in Europe is normally between 25 and 45 meters, then you can imagine that these kind of net of light corridors can act as a barrier to moth movement, because the attraction radius of 23 meters can, in many cases, overlap. And migratory species can lose valuable time and energy to reach their destination and to reproduce successfully. This is not only the case for insects or for moths in this case, It has been reported for fish, for bats, and I guess also for birds this might be the case. Insect decline. Maybe you pay also attention of these articles that were published, of this article that was published in 2017. And here, based on a long-term series of 27 years, the authors found that more than 75% decline in total flying insect biomass in protected areas. And this was covered by Science. And there was another German publication about a different data set, but also a long-term data set, which was reporting a similar effect, arthropod decline in grasslands and forests in this case. And both these studies, they stipulated that beside pesticides, fragmentation, land use change, there must be another landscape level driver, which could be important for this arthropod or insect decline. And that was the reason for us to check where the sampling locations were for this Krefeld study, for the first one. And in most cases, these sites were highly light polluted, as you can see it here. And there are some other long-term data sets that have shown that light explains changes in the moth abundance. In the Netherlands, for instance, nocturnal and phototactic moths show a stronger decline compared to diurnal. So there are also diurnal moths in non-phototactic species. And in the UK and Ireland, there was a long-term study where light pollution explains 20% of the long-term changes in moth abundance. Yeah, so if you think about the insect decline, you have to think always about the insect decline in the context matters. Because you have many insects are associated to plants, to crops. They have many different predators. And they fulfill important ecosystem functions, for instance, pollination and remyelinization of dead organic material. And we checked the literature and reviewed the literature and found that many of these associated species like crop and trees, pest species and their natural enemies, nocturnal pollinators and the ground-dwelling arthropod communities are impacted. In one example, for instance, 3 years ago, I guess, Knopp et al. Published a paper in Nature, I think, about the impact of artificial light on pollination, and they found that artificial light has a significant impact on the pollination efficiency of nocturnal pollinators. So they are not only the diurnal pollinators important for ecosystems, such as bees, but also flies, moths, and beetles are very important. And this pollination function was significantly decreased, and also the fruit building of these plants were negatively impacted by just installing a street light nearby. Yeah, in your conference we will hear a lot about mortality of seabirds, and that has been already also described in several publications, also for the area here where your main focus is. And it has also been shown that it is not only light pollution which is a threat for petrels. There are many other factors that have to be considered, although light pollution seems to be a really important one. And yeah, maybe I would like to point your attention then to an action program that was developed in Germany for insect protection, to protect insects and their biodiversity based on the evidence that also light pollution and other factors have to be considered when it comes to define comprehensive packages of measures. And this is a mixture, and that might be also good stimulus for your own project. So for instance, in Germany now, the binding statutory requirements are under an Insect Protection Act are developed now. It's in the process, and so it will be also manifested on a legal basis. Money will go to insect protection and insect research. The protection and restoration of insect habitats in all areas of the landscape should be supported. A clear guidance on sustainable application of pesticides and other harmful substances, because of course agriculture will continue to use these substances, but there might be ways to make it more sustainable. And one important point in this action program for insect conservation is mitigation of light pollution and insect attraction to light. And we are happy that the German government is considering this aspect, because we see that there is enough evidence to become active here. And of course, the last point, and you are following this direction already as well, the promotion and support of civic commitment for the benefits of insects in all areas of society. Yeah, how to use artificial light in a sustainable way? It's not so difficult, I have to say. There are some few rules that you have to follow, and you can reach a lot, but this has to be more accepted by politicians, of course, and the general public. Direct light where and when it's needed. One really important rule that everybody can follow, not only in the public, also in your private areas. So these kind of street lights should no longer be used. It should be a shielded light where only this area where a light is needed is used, and only during the time when it is needed. Customized color spectra. We know already that humans and insects, many insects, are very vulnerable to blue light and UV light, to short wavelengths. And if you know that humans or insects or other sensitive organisms have to be protected, then it is possible to customize the color spectra concerning the relevant organisms in the environment. And a very important point, light levels as low as possible. And this is something that has to be figured out with very different disciplines, of course, people coming from the security safety area, urban and land planners, architects, lighting designers, and many other disciplines. And by following this rule, and if you can use light in a more sustainable way. Yeah, this is, for instance, maybe this might be a camping ground on the Canary Islands. And if you imagine to follow all these rules, if these rules are implemented, then of course it could be possible to use light in a more sustainable way with less negative effects on the environment, but still humans are able to use light for orientation, safety, and security. And the advantages, of course, you can experience a natural night sky, like this one, a very beautiful picture about the Milky Way. And with this picture, I would like to thank you for your audience, for your attention. And I would like to thank all the different institutions that supported our projects since more than 10 years now. Thanks a lot.
Thanks, Franz, for your nice presentation. It has been a very wonderful presentation. I have enjoyed. I am glad to see that the German government want to mitigate light pollution impact on insects through this insect conservation program. Sorry, and this is a really good decision. I wanted to ask about that. Is there any law at the German country that they protect the insect or the invertebrates of light pollution?
Not really. We in one publication, we together with experts for environmental law, we analyzed the situation, and so far there is no really good. So the environmental laws do not really consider light pollution. It's a quite new stressor, and the legislative situation is not really prepared to that, but it's on the way within this Conservation Act that is in developing, is at the moment running. So people think about how this can be considered.
Okay.
So it's something that we have to expect in the future.
Would be nice to see what is the outcome of this law. You talk about the vacuum cleaner effect. What do you think about the similarities between birds and, for example, insects? Can this vacuum cleaner effect happen for birds, for example, migratory birds or seabirds, as you have talked?
Yeah, I think so far this interesting question that can be maybe analyzed in this way, but during bird migration, it has been reported that sky beamers or other light structures are attracting birds, especially when it is cloudy, and then it seems that they're very vulnerable. And also in your case, grounding of fledglings is a kind of vacuum cleaner like attraction of birds to these light sources.
Yes, because I have been thinking about that for longer, but I don't know if it's real a vacuum cleaner effect of a barrier to migration or a combination of them, because in the case of the bird, it's something the bird try to go from the land to the ocean.
Mm-hmm.
Then we could say that it's a barrier, if not to the migration, at least the movement, the barrier to the movement.
Yeah.
Obviously, it's also a vacuum cleaner effect because.
But of course, it is maybe it's increasing the landscape resistance. So it took them more time and energy to pass these illuminated areas, and which is also important, I guess, for many bird species, to save energy, which is needed, especially for these highly migratory birds. They have to migrate long distances, and if you have many kind of disturbances or barriers, then of course they waste a lot of energy that in the end is needed for successful reproduction, for instance. And of course time, synchronization, so that sexual partners meet at the same time at a certain point, is a very important aspect in ecology for many organisms. And this is also kind of landscape resistance aspect that has to be considered. If the synchronization is any longer than guaranteed when birds pass maybe extremely highly polluted areas.
Okay. Thank you very much, Franz. Thank you for your presentation. I want to remember to our audience that we have the chat. You can write your question if you want by the chat. Now we will have our next speaker, who is Teresa Jones from Melbourne Uni. Thank you.
Thanks a lot.
Teresa es nuestra última presentadora en el día de hoy y voy a saludarla en inglés porque ella es inglesa y vive en Australia. Hello, Teresa. How are you?
Hi, Adam. How are you?
Good.
I'm good.
How are you doing with the pandemic?
Oh, yeah. We're getting through it. It's getting better. So it's good for us now.
Good. Teresa is a behavioral ecologist with a particular focus on understanding the mating system, the role of the chemical cues, and most recently, the impact of artificial lighting on individual fitness and community structure. She completed her undergraduate at Imperial College of Science, Technology and Medicine at the United Kingdom, and her PhD at the Institute of Zoology. Since 2001, she conducted research at the University of Melbourne, and currently she is a senior lecturer at this university in the School of Bioscience. She is the principal investigator of the Urban Light Lab. The Urban Light Lab is a very recent lab which is publishing very interesting paper on this topic. And today, she will talk about how artificial light impacts on individual fitness and community structure. Teresa, it's your time, please.
I'm good to go. Thank you. I'll just share my screen and sound. Hopefully everything works. So thank you so much for this opportunity. It's fantastic to be presenting in the Canary Islands, even if I'm not there. I'm in Melbourne, where the sun is setting at the moment. So some of what I'm going to talk about has already been covered before, but I'll go through it very quickly just to make sure that we're all on board. So as you've already heard, light is a constancy experienced by life on Earth. And light is integral to so many processes. It's integral to our seasons. The spring, summer, autumn, and winter is driven by changes in light levels. It's also changes our hormones. Changes in hormones in spring, many new offspring are born. And it can also be linked to changes in the colour of skin and fur. But it's not just annual changes. Light is also integral to circadian rhythm. Circadian is circadian, about the day. Light determines when we go to sleep and when we wake for all of these different animals. For us, we wake in the day and we go to sleep at night. But many species are asleep during the nighttime and awake in the day. And these nocturnal species are quite plentiful on the planet. So more than 28% of vertebrates and 63% of invertebrates are nocturnal. And in that night also varies. So the darkness is not the same darkness over every single night. We have a lunar cycle, a moon cycle, and that can change the foraging behavior. It determines when some animals will go outside. It determines one of the largest mass spawning events on the planet, coral reef spawning. And it also can determine when some animals want to sing or not. This is a willy wagtail. It's a species we have here in Australia. This, hopefully you'll be able to hear it. Oh, no, you can't. What you can hear there is a willy wagtail calling and another one calling back. And you'll notice it's very quiet. And that's because a recent student of mine, Ashton Dickerson, has found out that the willy wagtail is a prolific nocturnal singer. So it sings at night. And the amount of singing varies over the lunar cycle. So it likes to sing on a really big, bright moon. It's a very visual species. So it likes to sing and be seen. So light also controls the communication and it controls the behavior. But light doesn't always, it's just not the intensity of light, but also the color of light that's important. And that's been important for 4 billion years. And if we think about when life first evolved on the planet, it evolved not like the willy wagtail in a tree or on terra firma, it actually evolved in the ocean. And if we look at how light passes through, and I know you will have heard some of this already, we can see that light passes through differently. And in fact, blue light passes really far down through the ocean. And so provides one of the best representations of when it's day, when there's lots of blue, and when it's night. And this is the color of light that life on Earth uses as one of the primary signals of biology. And in fact, our own visual system and our non-visual signal system is based on this colour of light in particular. So our visual signal, I'm not going to show many graphs, but here's one. The V is what we can see. Humans can see between about 400 and 700 nanometers. We also have another system though called the circadian system. And this is a non-visual photoreceptor. And this peaks around blue. And this circadian system is partly driving our day-night rhythm. And in fact, this blue peak is very ancient. And we can find it not only in humans, we can find it if you look down here in all of these different bacteria. And these green cyanobacteria were the precursors to plants. And it's also present in plants. And in fact, many of you may turn your phones. My phone is doing this right now because the sun is setting. My phone turns into the red at night. The blue is being shifted away. The reason for this is not just because it's making me sleep. The reason is because 4 billion years ago, blue light was an important trigger, for life in the oceans to distinguish between day, when it was very blue, and night, when the blue was reduced. But light itself is not the thing that drives the biological rhythm. It's changing our biological rhythm, but it also relies on chemicals and neurons in our body. And one of the key chemicals that life on Earth uses is melatonin. And melatonin is present across much of life, the really important ancient chemical. And it has a rhythm to its production. You can see here this wiggly line represents the melatonin concentrations in my body and indeed yours. So at nighttime, melatonin is peaking, but melatonin is sensitive to light. So in daytime, my melatonin concentrations are dropping. They rise again at night and they drop in the day. And melatonin is one of the chemicals involved in driving our circadian rhythm. And this is what it's best known for, as a biological indicator or timekeeper. And many of you, if you travel across to a different time zone, if I were indeed to fly to you, if only I could, my body would be out of sync. And one of the chemicals that's out of sync is melatonin. It takes a while for that to catch up. And some of you may take melatonin to help you resync your body. Now, whether that actually works is probably a subject for another talk, but it's a really good segue into the second and lesser known function of melatonin, which is as an antioxidant. So an antioxidant mops up potentially dangerous free radicals that are floating around our body. They're natural byproducts of metabolism, but they need to be soaked up by these antioxidants. And so for 4 billion years, for life on Earth, melatonin acted as a driver of biological rhythm and also as an antioxidant, a protector of the cells of life. But melatonin is sensitive to light, and it's also sensitive to light at night, artificial light. So in the presence of artificial light at night, melatonin concentrations decline. And so that protector of the cells of life, the driver of biological rhythm, is compromised. And it's compromised globally. This, as all of you will know by now, is a composite image of light at night across the globe. And in fact, up to 20% of land mass is covered by light at night. The top photo there is Melbourne. It's where I live. That's our city centre. And it's not so different to many city centres around the world. On the right-hand side, you can see a sports ground. This is where my sons play football and cricket. You can see the big bright light shining in the foreground, and you can see the full moon rising in the background. So given the importance of light, for life on the planet, we can only start to imagine how important it's going to be when we start changing those cycles. And this is where light pollution comes in. So I'm going to give you a potted history of some of the work that is going on in my lab. I'm not suggesting it's the most important, but it's some of the work I know best. So I'll give you just a little bit of insight into where we've been looking at the individual and, as Aaron said, the community level impact. We contributed to a recent JZ journal issue. And on this front cover, you can see all of the potential impacts of light at night. You can see that light at night, the light that's shining down, is masking the light cycle. It's no longer dark. In fact, we can see colour. We can see like daylight. It's changing behaviour. That willy wagtail that I showed you before is now chasing after a moth that's flying up to the night. It's disrupting the sleep of both of these species. And what you can't see, and something we think is much more insidious, is it's also potentially disrupting physiology. So I'll go through some of these things in detail and show some examples from some of the work in my lab. I should say most of this work is from my students, and I will try and acknowledge them as we move through. So light at night masks sunrise and sunset. It's not daytime, but it certainly masks that period of night. The willy wagtail that I showed you earlier, and these cricket species, here's one here, this is the mole cricket. And this is a field cricket. This is my model species of choice, which I think has got quite a beautiful sound. What we know about that from studies that we've done across the landscape in Victoria is that in urban environments, their communication shifts compared to the rural, natural environment that they live in. So we're changing their behavior. It's masking the time when they would normally start communicating, and it's disrupting the length of time that they communicate for. So it's changing an aspect, a really important aspect of their behavior. And light at night, we know, shifts behavior. It affects foraging and movement patterns. Let's not get me wrong about this. Light is put there because it changes my behavior. When the light is put there, myself and my sons can go play footy, or we can go and kick a ball around. But it also affects the foraging and movement patterns of other animals. The turtles are a classic example. Instead of moving towards the horizon, if lights are on the beaches, they move inland. Some bat species are completely terrified of the light. I say that's quite anthropomorphic, but they move away from light environments. And one of the other things that we know is that light is disrupting physiology, and I'll talk about that in a moment. It's changing foraging, it's changing metabolism, and it's now been linked to increased levels of obesity. So light can attract. We've known that. Aristotle's known that. He's talked about a moth to a flame. But what if it's tens or hundreds of moths to a flame? And what if it's thousands, whole communities? Then what? What we're doing here is disrupting not just the individual's behavior, but also the behavior of a whole community. But one of the things about biology is often where there's a negative, there's a positive, there's a yin and a yang. And all of these species potentially benefit because the insects are attracted to lights. So spiders, geckos, and bats, if they don't mind the light, can feed upon these insects rather like an invertebrate sushi train. This spider you can see here is a nocturnal garden spider. We don't have a torch on it. It literally is building its web underneath a bright street light. And my student, Nick Wilmot, who's shown there in the top, did lots of experiments for his masters. And what he showed is that they actually preferentially go towards the light and build their webs under these street lamps. And the reason for that is that these webs then attract lots and lots of insects. So they gain a resource by feeding. Now, what I'll also show you later is that physiologically they are compromised. Now, the species that I've just shown you are mostly nocturnal, so they're usually active at night. So light at night is not necessarily disrupting them to the same degree, although we know that it is increasingly doing this. But what about those species that are usually day active? Light at night is changing our night. It's making it brighter. And we know that this affects sleep. It affects sleep in myself and my children. It keeps us awake at night, particularly blue light is really important. Now, this is a study that's not my own, but it's certainly one that's really interesting because it shows that the effect that light at night has isn't always the same for all individuals. And in fact, in humans, we know that light at night is way more detrimental to children than it is to adults. In this study, what they did was they exposed adults and children to two different colors of light, a very bright blue-white light, a 6,000 Kelvin, and a dimmer, almost orangey light, 3,000. And then they tested sleepiness at bedtime, which is BT, and 1 hour past bedtime. And you can see in adults that the presence of light at night affected their sleepiness. They weren't as sleepy, but they did tend to get more sleepy as they went past their bedtime. And that was roughly the same for both colors of light. But for children, again, they were affected by both colors of light at bedtime. If they're exposed to a yellowy light, though, they did tend to feel quite a lot more sleepy a bit later. But if they were exposed to the blue-white light that you can see here, they actually still didn't feel sleepy. So it's having a massive impact. And so that's within individuals in a species. But what our research is also showing is that it's not just within individuals in a species, it's actually different for different species. Some work that my now doctor, Anne Olsenbrook, did for her PhD looked at the impact of light at night on sleep in avian species. In her work on the urban black swan, she used loggers to actually measure sleep. And what we found was that in the presence of light at night, swan's sleep was disrupted and they were way more active. And we literally did this by translocating swans into a parkland that was quite dark. And we put a street light, this one here, this is a real street light. We just put it onto a pole and we either shined white or amber light. Regardless of the color light, the swans were disrupted. So rather unusually, taking away that blue light still had a massive impact on swan sleep behavior. So Annie then repeated this in the lab using pigeons. So she did it here and found exactly the same thing. Even taking away the blue light, rather surprisingly to us, melatonin concentrations seemed to still be affected, but more importantly, sleep was still massively impacted. We then did another study where we actually looked to see whether it was the fact that we put light there all night or whether it was the color of light that was important. Because one of the things you do when you shine a light is you make it brighter, you make it more visual, and it may be that birds are more active because they're scared of predators. On the other hand, it may be because it's being affecting their melatonin. So to test this, we did another experiment with Farley Connolly here in magpies. And we did the same experiment, only this time we shut the light off after 4 hours. And we looked to see what happened. Now, interestingly, in the magpies, they were way more sensitive to blue light than amber light. So amber light was a slight mitigation strategy for them. But they also recovered really rapidly, suggesting that maybe it wasn't just the physiology, but also the fact that we changed their visual environment that had an impact. But that physiology is something that we didn't do as much in this particular group, but we certainly did in other species. So we looked specifically at light at night disrupting physiological process. And we go back to that melatonin. Melatonin is driving circadian rhythm, but it also acts as an antioxidant, and that has capacity to affect massively physiological process. If we look across a range of different species, what we can see is that melatonin is, light at night, is associated with lower levels of melatonin. So most of the species, except for the cricket, are ones I don't work on, but they've all demonstrated that in the presence of light at night, melatonin concentrations drop, as we saw in that graph. I did an experiment in the cricket, Teleogryllus commodus, that I've just played you. The same thing happens there. In the presence of light at night, melatonin concentrations lower. This then means that that protector of the cells of life and driver of circadian rhythm is compromised. And what we found accordingly is that light at night affects some of our key life history traits, things like growth, reproduction, and survival. Again, it affects in all of these vertebrate species. I've not worked on these in my lab, but there's some really good evidence, and that evidence is increasing. But it's also been shown in invertebrate species, these spiders and insects that you see down here. The spider that I showed you earlier, that one that benefited from all of those insects being caught in its web, when we took away that benefit, when we gave spiders that were reared under lights or no lights the same food, so we took that benefit away, what we found is that the spiders under no lights were much bigger than spiders reared under lights. But more importantly, they laid almost 70% more offspring. These are tiny little spiders' eggs. So poor Nick analysed about 140,000 eggs during his master's project. So this is demonstrating that urban spiders, even though they're benefiting, actually there is still a potential physiological cost that we can't see because of the benefits of those insects that they attract. Now, interestingly, in spiders, the number of offspring or babies that you have is directly linked to your size. Now, that's not the case for all species. And in the cricket species that I work on, and was worked on by my master's student, Joe Durrant, and an honours student, Michael Botha, In this species, we also found a shift in development time and also development with respect to light at night, but it actually increased juvenile development. So light had the opposite effect. So again, we're seeing differences across species. It changed development by about approximately 10 days. Now that doesn't sound like a lot, but it's about 15% of their life cycle. And that might mean that they have less generations in any given year. What was also important about this experiment is it showed us that at relatively low levels of light, 1 lux, which is really tiny, these impacts were already being felt. And finally, my student Lucy also did experiments in Drosophila melanogaster, and she confirmed, you don't necessarily need to know the details in this, but again, exposing to different levels of light, we found impacts on fecundity, so the total number of offspring went down in the presence of light, and also adult survival changed. So all of these traits are changing in the presence of light at night, suggesting that urban species may be impacted. One of the things we're increasingly now realizing, and is realized in the medical field for actually quite a number of decades, is that light can potentially affect health. The top species here are the animal species that we know in the presence of light at night have compromised or at least altered immune systems. The World Health Organization and the American Medical Association have both declared night shift work in the presence of light at night to be potentially carcinogenic. And blue light in particular is something we need to consider and is of importance in driving some of these patterns that we see. Most recently, or at least over the last decade, light pollution has been implicated in global biodiversity declines, so reductions in vertebrates and invertebrates. You've already heard a number of instances where this has been exemplified or shown. Some recent evidence suggests that even pollinators, those really important species that are pollinating our flowers, are declining also. Our data is also suggesting that in the presence of light at night, so under normal streetscapes, the number of invertebrates and the composition of those communities is also changing. So this is Marty Lockett. He did a massive experiment replicating one that Jonathan Davies did a number of years ago. Here we found something slightly different, but we're still finding a direct impact of light at night on the communities of invertebrates that are trapped under lights at night. So in night samples, the communities and the number of invertebrates captured are reduced compared to samples that are taken between lights, under lights. One of the things that I'm most interested in at the moment is looking at whether light at night is driving not just changes that we can see, but also whether it may be changing some of the genetics, driving evolutionary change, maybe driving new species or changing the genetics of particular species. And that's something that is gradually becoming more and more important, and certainly something that's been worked on in the field of ecology or urban ecology for a while. So we face a problematic future. On the one hand, humans love light, and we know that some species like these urban foxes will do really well. The problem is that as humans, we love light, and we're quite a visual species. And so to take it away is really problematic for us because we perceive it as safety. It's also becoming, as you've already heard, we're seeing a global shift to LED light technology or streetscapes. So LED lights have a change in the color, and they shift from this orange lighting that you see here to the blue light that you see in this spectrogram here. So this is revealing the different colors of light that are being emitted from the LED light. And it's not going to go unnoticed to see that that's coinciding perfectly with our own circadian and indeed visual spectrum. So what we hope is for a not so bright future. There are different technologies that are now being employed, different ways in which we can mitigate some of the impacts of light at night. Ultimately, when Edison first turned on the light, this is what each room and each electric light was equipped with. This room is equipped with Edison electric lights. Do not attempt to light with match. Simply turn key on wall by the door, which is why we turn on the light, by the way. Importantly, Edison felt that electricity for lighting was in no way harmful to health, nor indeed does it affect the soundness of sleep. hopefully I've shown you that that's probably not the case, and we may need to rethink this. Edison also thought there was really no reason why men should go to bed at all, so maybe he wouldn't care, even if he knew this. But for me, I also take that women should go to bed, and I'm quite happy to do so. And to do so, what we need to do is turn off those lights, because it's all important that we put ourselves under our natural light environment, not the one that the 21st century has provided. So with that, I'd just like to thank my amazing lab. I live vicariously through the work that they do. Here's a suite of all my students that have contributed to some of the work that I talked about today, and also to the funding bodies, the Australian Government, the Herman Slade Foundation, the Holsworth Wildlife Foundation, and also BirdLife Australia. Thank you.
Thank you, Teresa. Thank you for this nice presentation.
I'm sorry about the background.
Don't worry, it's fine. Thank you.
Hopefully you can get rid of it.
This has been a very illustrative presentation by Teresa. I would like to make one little question, or maybe two. What do you think about how light pollution will drive the evolution?
How light is going to, I don't know. I mean, I think one of the things it might do is it might depend on where those species are. So some species are going to be quite adaptive, plastic in their response. So they're going to be okay. Those might be the species that are already really happy in a rural environment and really happy in an urban environment, already found there. But whether it then changes, if we're seeing changes to when animals are communicating, or maybe even the types of songs that they're using to communicate, then it might be that in our cities we start seeing a pulling away of that communication, for example, from a rural species. And it might not make much of a difference at the border. There may be enough overlap, but in the city, they might suddenly start getting new populations that are quite different. So we may see speciation based on communication.
Makes sense. I was thinking during your presentation about your studies on the spider. You saw that the spider use the light to build their webs, yeah, and hunt for the insect that they are attracted to the light. Yeah. But then you saw also that the spider left, they are smaller in size, and they also lay less number of eggs.
Yeah.
Yeah. It clearly seemed a ecological trap.
It's what? Sorry.
Is that one ecological trap?
Yeah, maybe. Well, I think actually what's happening is that it's not because they're still getting, because they're getting lots more food, it's overcoming the ecological trap. So it's a weird ecological trap.
Yes.
Yeah. But actually what's happening, I forgot to say, is that they're only passing through about 2/3 of the molts. So spiders molt their skin as they get bigger, and the ones under light go more fast and have less molts. So they're actually changing their development under light if we keep food constant. So under that scenario, it's changing physiology.
Okay, but my question was, if we follow this example, this model species, the spider,
yeah,
could we make a similar thinking with the human? For example, we work at night, we change our behavior, our activity, yeah, from diurnal to nocturnal. The same what is happening to the spider can be also happening to us.
Yeah, no, that's a really good point. I mean, I think it's possible that we can, people still take melatonin and they take things. If you feed yourself properly, I guess, you can overcome some of those. The thing about sleep deprivation, though, is we know it's really bad. So if you're changing your sleep, it's almost like being drunk. You know, one sleep-deprived night is like being, in Australia, 0.05, which is over the limit for drinking. So now, whether we can overcome that, I don't know. I think some of the things we can. I think that loss of sleep is possibly probably going to be one of the most problematic things as we move through into the 21st century, So.
Okay. Thank you very much, Teresa, for your presentation, and also thanks for your answer to my question. I would like to remember that the chat is open. You can write your question if you want to discuss, use it. And now I'm going to, Teresa is the last presenter of today, and tomorrow we will have more presentation. And now I will talk a little bit in Spanish. Teresa es la última presentadora por el día de hoy, y mañana tendremos más presentadores con más temas acerca de la contaminación lumínica y las luces. Recordarles que tienen el chat abierto para poder escribir cualquier pregunta que quiera que Teresa o que nosotros contestemos. Y muchas gracias, nos vemos mañana. ¿Vale? Hasta luego.